Good morning, good evening, good afternoon. My name is Keith Pascal. Today we're going to talk about special joins. So a join relationship is a regular, they're a regular relationship and they're join relationships. A join relationship is one that looks at attributes of different CIs and then can create a relationship between them. You can either show the relationship or not in your finished TQL, but it will impact the TQL results. We'll look at a pretty good example of that here. This relationship compares the agent, the agent CI and its application IP, and it must equal the IP address, the name attribute of the IP address. So the application IP is the IP, for example, that an NTCMD shell or something like that sits on. And if that is equal to the name of an IP address, which is the IP address as well, then it fulfills that relationship. Now you can give it a different name other than virtual join, and you can show this relationship or not in the query results. That just means it'll show a link between there if you want to show that link. If you don't want to show that link, it will not show the link, but it would still modify the TQL. It will still modify the results that you get. And you can specify that I want this relationship to go from the agent to the IP address. So for example, over here on the left, I had 2 nodes with 5 IPs and 2 agents. Now, some of you with sharp eyes might see that there are 6 links between these 5 IP addresses and 2 nodes. One of the IPs is shared between these 2 nodes. So that's why there are 6 links, but there's only 5 IP addresses. Anyway, there's 5 IPs, there's 2 agents. When I calculate those results, that's what I get. When I compare the agent application IP with the IP address name and put this virtual join in, you can see it now restricts it to 2 IP addresses with 2 agents on 2 nodes. So this is a much better picture, and it answers a specific question. And that's all TQLs do, is they answer specific questions. Here's another one. We can use substrings as well. A network an IP network address. It would be listed as something along the lines of 10.0.0.0, for example. That is the network that this IP is on, right? And on an IP subnet, its display label is 10.0.0.0/8, right? That's the subnet mask if you were unaware. So what I'm saying in this is the network address must be a substring of the display label of the IP subnet. You could always use the name, I believe that is where that's at. We're calling it a virtual join, and we're showing the relationships, and now the direction will be IP address to IP subnet. So that would work. All right, there are also compound relationships. This is not a virtual join, this is a compound. It's the one right below that. And that is a relationship where the full connection path between the CIs might not be desirable, usually because it makes the map super messy. Over here, we have this query that goes from node to running software to IP service endpoint, and notice the directionality here. Database connects to the IP service endpoint, as does the node connecting to the database, all right? It's all in this direction, right? And this is the result of that TQL. Well, if the question that I'm trying to answer is what nodes are connected to which database servers, you know, I've got to really zoom in on this TQL to try to figure out what answers my question. And for example, is this a node and is it connected to that node? Well, is this node connected to this node? Which one of these is database servers and which one of them are, you know, nodes with running software? I don't know which is which. It's a very confusing TQL, but it may answer the exact question that I need. So what we can do is go and create this compound relationship. And what you do is you specify all of the hops inside this compound relationship, right? It's from node, composition link to running software in the direction of node to running software, running software usage to IP service endpoint in the direction of running software to IP service endpoint. IP service endpoint usage database in the direction of database to usage to IP service endpoint. And then database with a link. Now this link is the top level thing. I would actually say composition with a node and in the direction of node to database, right? So this is all of the hops. It represents the previous graph that we saw. Again, the relationship name doesn't have to be virtual compound. You can fix that if you want to. And you can also step your minimum and maximum steps. So for example, a node connected to running software, connected to an IP service endpoint, connected to a database, connected to another node, where that node is also connected to a running software, which is connected to an IP. So it'll chain them together. Those are the compound levels that we're talking about. And you can stop at the first one. You can also show this element or not in the query results being a line. And you can click this to show the full path between the source and the target. And here's our relationship direction is from node 1 to node, right? In that case, it's going to be my database. And in this, we say allow non-self relationships only. And this is important because, for example, node running software is a database is a child of running software. So if I have a node connected to a database, connected to an IP service endpoint, it logically has that IP service endpoint connected to a database, connected to a node. But I wouldn't want that node pointing at itself, right? So this is non-self relationships only. And then you can click OK. Here is what I get out of that, right? And it's much easier for me to see that it goes from the running software CI over to the node that it is connected to. This is the database server. These are the servers with running software that connect to it. The same thing is true here. This is the database server. These are the running softwares that connect to it. And you can tell because of the direction of the arrow, right? So it makes this graph much more understandable and much more readable. You can also fold those underneath each other so that I can see at the top level, what are my database servers, right? What are my database servers? Calculated links, those are another type of link, but those are defined by triplets. And to go, you need to see what they are. You need to go into CI type manager, select the calculated relationships dropdown, and then select the triplets tab in the particular relationship that you want to look at. This is most commonly used in impact analysis rules. So what I can see here is, for example, I have all of these CIs. This is the impacted by directly, and this is something that you can use in impact analysis. So if I have, for example, this J2EE domain with a composition link to a J2EE cluster with the directionality going from the domain to the cluster, and I select that there is some problem with this J2E domain, it will show me that this is impacted by directly, right? So you can follow these and you can add them, right? So if you have your own CI types, you can add those in here and get your impact relationships done as well. Thanks for your time, and I hope you have a great day.